Okay, so from yesterday, real quick. When we're looking, let's do a quick review. Okay. When we're graphing, which one starts up here? Cosine. That is cosine. Okay. And then the other one, sine. Okay. You guys memorize it however you want. It doesn't really make any difference to me. And hopefully you're also not only memorizing that, but you're now seeing the fact that you can go ahead and find the sine of your 0, your 90, 180, your 270, your 360, all by looking at your graph. Sine goes from 0 to 1 to 0 to -1 to 0, all the as you go through your multiples of 180. Yesterday, I asked you to do a couple different things. Like 1 through 7 odd. 1, it's just half as tall. 3, 6 times as tall. 5, that one was y equals sine of 4x. Okay. I want to review just one thing here real quick. Do you recall the International House of Pancakes? Yeah, so it stands for inside, horizontal, and it's the opposite. Okay? Inside causes horizontal change, and it's the opposite of what you might think. So this right here, that's causing horizontal change. It doesn't slide it that way. Since it's a multiplier, it's either stretching it or shrinking it. It looks like it's going to stretch it 4 times bigger, but it's the opposite. It's going to be 4 times narrower. Okay? And remember, the reason why that is because it's artificially blowing up my x value. So if I'm looking at degrees, if I just put in 90 times 4, then it's going to be 360, and it's already at the end of my cycle. Okay? So anyway, so this one on number 5, it's going to have a period that's only 90 degrees, or pi over 2. 7, that's cosine of 1/5 x. Okay? So this one, cosine, it's going to start high like normal, but what's the 1/5 going to do? Stretch it. It's going to be the opposite. It's going to be 5 times longer. So instead of a 2 pi period, it's going to be 10 pi. Instead of 360, it's going to be 1800. Okay? So, but today, we've actually got a lot of work to do, because by the end of today, let me ask you guys a question, because I'm making an assumption, and I should probably ask you a question. Have you guys ever graphed something like this before? No. Okay. And I wouldn't anticipate that, because to do this in Algebra 2 instead of PreCalc would be just really outside of the norm. Okay? So today I'm going to take the time, and we're going to make sure we understand all the different parts and pieces of this before we start and do any more. Okay? So I'm going to set this aside. That's the assignment on 15, 17, 19. Let's take a look at this sheet. Okay. So what we're looking at here is well, first of all, can you think of, first of all, our goal in the mathematics we learn should be what's useful. Can you think of anything that would go up and down and up and down and up and down that a person might want to model? Stocks? Okay. Stocks, it's kind of interesting. There's actually been some research that shows stocks actually, they go kind of like a sine, but then vertically canted at the same time. Okay, so it's like a little combination. So it's got parts where it goes up and comes back down, goes up and comes back down. Okay? What else? What else can you think of that goes up and down and up and down and up and down that we might want to model at some point?
Temperature.
Temperature. Exactly. Temperature throughout the year. Okay? So this one might be a good example for something in the southern hemisphere. Okay? So in January or February, you have your highest temperatures. And then maybe this is down in Australia. Okay? And then you have your lowest temperatures when we would have our highest temperatures. Okay? Due to the tilted axis of the Earth. Okay? What else might go up and down that we want to model?
Gas prices.
Gas prices, possibly. I could see that. But gas prices is really interesting in the sense that usually the prices has some external influence, like a world conflict or something like that that's really hard to predict. So while we might be able to see some patterns like that, it would be hard to maintain that. Other things you might see, definitely I like the temperature idea. A tide goes up and down and up and down. But the amount of daylight, right now we're in the trough on our daylight.
Your heartbeat.
Heartbeat. Ooh.
My grades.
Yeah. So this is like when a person does their homework, and then maybe when a person doesn't do their homework, and then they remember, oh, I got to do my homework, stuff like that. Okay? I don't know. Okay. So anyway, this is, that's one of the first things we should ask ourselves, is this worth doing? Well, it is worth doing. Okay? So let's go ahead and define some things here. And my apologies for giving you guys something that took a little longer than I anticipated. So that's why I'm trying to use time a little better today. Here's what we have. Y equals A times sine. This could be cosine as well. Okay? I do want you to realize that if we go ahead and come up with something on our graphs, okay, if we go stat, calc, and we come back down here to sine, it's always going to give us a sine regression. It's never going to give us a cosine regression, okay? But in what we do here today, cosine can be very helpful, okay? So, anyway, but cosine can be nice. This D, started to pick this up yesterday. The D is how much the whole thing's been vertically shifted. And if we remember the... Shay, all right. Okay, I wasn't sure if you... Okay. This is how much has been vertically shifted. And that right there, that in the past has been our upward shift. Okay? In the past, this A has been our stretch. Okay? What's going to vertically happen to it when it stretches? So this is our vertical shift. This is our vertical stretch. So this gives me how much it's been moved upwards or downwards. And this A is how much it's been stretched. Okay? So if A is 5, my amplitude is 5. Okay? Now the B and the C are a little bit more mysterious. My B gives me my period, which I threw this at you real quick as you exited yesterday. But if I take my normal period, which is 2 pi, and I divide that by B instead of multiply by B, that gives me my new period. Okay? And another way to write that is 360 over B.
Could we write this down, or just like...
I would write it down. Oh, yeah. That's why I prepared the sheet for you, so you guys would have this drawing. And I worked hard on this drawing to sketch it out so it looks so pretty. Okay?
So our B's are blue. Like that looks good.
Did you notice?
The shoes?
Yeah.
Kenzie made a comment.
Oh, really? They're brand new. I'm so excited. Whenever I can find a pair of Brooks for $110 instead of 160 or 170, I'm going to pull the trigger. So, anyway.
So our B's are period.
Our B impacts your period.
Oh, impact.
It impacts my period. Okay? So, and why is it divide? Can anybody tell me why it's divide? Why it's my usual period divided by B instead of multiplied by B? Okay, back to my normal x, and it's inside. So it's the opposite. Instead of making my period that many times longer, it's instead of times b, it's now divided by b. Okay? No, c is something different. Oh, okay. Anyway, I'm just joking. A is my amplitude, yes.
And then D is?
D is my vertical shift. Okay? Okay, I'm going to throw some formulas at you here too. Okay? So this impacts my period. I'm not going to write period because I don't want you to look at it and say, "Oh, that's my period." That's not. Okay? And this right here, in combination with that, impacts my phase shift. In other words, my horizontal slide. Okay. If I would factor out of B right here, what would I have left? X plus C over B. Okay. What could I what could I plug into this inner parenthesis to get 0? Not C over B, but
B over C.
no. Plug in here to get 0. What plus C over B gives me 0? Negative C over B. Nice job, Rolo. Okay. So this right here, hanging out, that is my phase shift. That's my horizontal shift. So my horizontal shift, and I'm going to clarify all this with examples today, or they call that my phase shift, is negative C over B. Okay? So let's take a look at these 4 examples. We're going to sketch these out super quick, and we're going to go from there. Okay. 4 cosine x plus 3. Tell me what you know about it. Amplitude is 4. Okay. Up 3. So my center line is up 3. 1, 2, 3. So I'm going to put my center line first. Okay. From that 3, how much higher will it go?
4.
How much lower will it go? 4. So here's what I like to do. I'll go up 4 units. 1, 2, 3, 4. And I will go ahead and put a ceiling. Down 4. 1, 2, 3, 4. And I will put a floor. And now I've just got to draw my cosine. Okay. This one has not been horizontally impacted at all. There's nothing being done to my x. It's just x. So I've got my little box that it's got to live in. At 0, where's it going to be? Top, middle, or bottom? Cosine.
It's going to be top.
Top. And let's just pick another point over here that's going to end up back at my top.
Oh.
And I'm just going to say that must be 2 pi. In the middle, where's it going to be? In between 0 and 2 pi, where's it going to be? Bottom. And that would be at pi units. And then in between there, it's going to be in the middle of those. So this would be at pi over 2. And this would be at 3 pi over 2. And then we just go ahead and sketch cosine. Okay.
I do not like that 100.
Okay. Yeah, I don't really like it either by the looks of it. But you know what? I like conquering things that look difficult. Okay? One thing I want you to think of, okay, we'll just kind of take a break and we'll think about applications go. Let's say if this was the length of the day. Okay, I know that the scale's not right in this, that, and the other. But the longest number of hours happen in the summer, right? And then you get down here, there, this is, so for this would be like it'd be June, right? June. And then this would be December, the shortest days, okay? But the one thing I want you to keep in mind too, it's kind of getting you ready for calculus, is that when is my daylight changing the quickest as far as the length of the day? Is my length of the day changing very fast right here? No. It's almost horizontal for a little bit. And then through here, the length of your day would be changing quite quickly. So for right now, we are approaching the longest period of the day. The shortest period of the day. You're not going to see much difference from day to day to day to day because we're down in this little trough, which I'll talk about a little bit later on. Okay? Okay. So, bottom line, find your middle, do your amplitude, and then we'll worry about where our placements are at. Next one. -5 sine of x over 2 plus 10. Ooh. Before we even get started to draw, what's my middle line going to be? What's my highest it's ever going to get?
5.
No, my highest it's ever going to get. If my middle line's 10, 15, and my lowest it's ever going to get is 5. So now what we're thinking is we're kind of thinking ahead about how we're going to draw our picture here. So I've got my center line is going to be 10. The highest it's going to go from there is 15. Why? My amplitude is 5. And we're going to go down here to 5. And that's the lowest it's ever going to go. What's my period going to be? Let's do it in terms of degrees first before we stretch it back to radians. My period is impacted by this x over 2. 4 pi or 720. Okay? Now, how do we know it was going to be 4 pi? Well, you multiply by 2, right? Because it's the opposite of divided by 2. There's another way you could do this if you want. You could see that, okay, use your formula. I know some of you guys just love formulas, okay? We could use this formula right here. It says 2 pi over b. 2 pi over 1/2 is 2 pi times 2 over 1. So that's 4 pi. This one with the x over 2. Has it been slid left or right or not at all?
Wait, so how do we get the period?
How did you get the period? Okay, that's great. That's great. Good question. You can go back to your formula. 2 pi is my normal period. I'm going to divide it by 1/2. Because my x, another way to write divided by 2 is times 1/2. Okay?
Oh, okay.
And I think the next one will even make it more clear. Okay? So this one, has it been slid left or right? No, because there's no plus or minus. And if you want to think about it this way, if you think about our C up here, the plus C, what's C in this case technically? 0. So it's not moving left or right. So we've decided our period is 4 pi, so I'm going to come out here and let's just say this is 4 pi. This is 2 pi. This is pi. I don't know why, but I'm getting hungry. And then we get 3 pi, which I was pretty upset. Thanksgiving, there was a bunch of pumpkin pie, but nobody brought chocolate pie. Ugh. 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 Okay. So here we go. Sine. Let's look at my box. Where's my sine going to start? Top, middle, bottom? No. Sine. Middle. Sine starts in the middle. Sine starts in the middle. Okay? Sine starts in the middle. From there, This one, since it's negative 5, it's going to go down, isn't it? Okay, good. It's going to go down here. And then what's it going to do? It's going to go back up to the middle. And then it's going to go back up to the very tippy top. And then it's going to come back down there. Oh, that was ugly, ugly. Okay, so that's what that graph's going to look like.
So on the last graph, the highest it could go was 4, you said?
From my midline, yes. Yep. So it's starting out like right here, GG. It's starting out at 3.
Yeah.
And from there, I can go up and down 4. Because I'm starting at 3, and then from there, I'm going to go woo boo woo boo woo boo, 4 units each way. Okay. Ooh, we got to do a monster one. 1/2 sine of x over 4 minus pi over 2 minus 3. Okay. Looking at this just kind of makes you want to throw up in your mouth a little bit. But you know what? We don't run away from challenges here. So let's just do some calculations before we even start drawing. Okay, what's this minus 3 tell me? Down 3. What's this 1/2 tell me? Up 1/2 and down 1/2. So then we know where it's going to be graphed. Okay, so I'm going to come down here. 1, 2, 3. There's my midline. And then from there, it's going to go 1/2 unit up. This is going to be a short, squatty little guy. Okay, so my midline was at 3, and I'm doing plus or minus 1/2 because my amplitude is 1/2. Now we've got some other work to do. Let's find my period. What's my period? 8 pi. Nice job, Blake. Okay? Because if we want to go 2 pi divided by 1/4, 2 pi times 4 over 1, which let me get my calculator, gives me 8 pi. So then what I can do if I want to, I can go ahead and say, let's just delineate this. This is 8 pi. Whoa, no. Time out. Let's not do that yet. What did I forget to do? I got to do my horizontal shift in addition to that. Okay? But from highest to low, or from, when it starts repeating itself, 8 pi. Okay? So now we got to do something else. My phase shift. My phase shift is by its negative c over b. I'd like to, let's just kind of squeeze this in over here. My phase shift is equal to negative c over b, which is pi over 2 divided by 1/4 equals pi over 2 times 4. Okay, this doesn't feel right at all. 2 pi. Yep. Okay, now, don't let that freak you out. That's not my period. That's just how much it's been slid over. Okay, so this is always kind of a little sticky point. Where does sine usually start? At the origin, right? So I need to start it over here at 2 pi. How far is it going to go over? 10 pi. Why 10 pi? My full period is 8 pi. So from 2 pi plus another 8 pi gives me up to 10 pi. I'm going to give you a little secret that I've not seen taught anywhere, but this is kind of a nice little thing here. This is really, really slick. Check this out. You don't have to write this down. I'm giving you another way to do it. If I set that equal to 0, that tells me where it's going to start. My sign usually starts at 0. So if I set that equals 0 and solve it, that'll tell me where it starts. Okay? Where does it usually finish? Where does sine usually finish? It usually starts at 0 and ends at 2 pi. So if you don't like, this other deal that we just got done doing, and we'll practice this here in just a little bit, so don't worry about it yet. You know what I'm going to do? I'm going to multiply by 4 because I don't like this fraction stuff. Is that all right? You all right with that? Okay. So x minus 2 pi equals 8 pi. X equals 10 pi. So that's the value of x that I start at. This is the value of x that I finish at. If you like that, there's 2 ways to do that. So if you want to, let's go back to this. My starting x, here's what you can do. Bx plus c equals 0, and then solve. My ending value of x, bx plus c equals 2 pi, and solve. If that helps you, great. Otherwise, you can find your phase shift and your period, add them together. You can do it either way. And we got another example coming up. All right. So now, my guys might be thinking, okay, great, Rexroad, now what? Well, here we go. It's starting at 2 pi, ending at 10 pi, and all we got to do in that little box is draw sine.
So start in the middle.
Start in the middle.
At 3.
And I'm going to end at the middle, right?
Yeah.
And in the middle, I'm going to be at the middle. And that would be at 6 pi. Good job. Ooh, you guys can't see that very well, can you?
So the 8 pi is just irrelevant?
No, not necessarily. The 8 pi is the distance from here to here. That's my period. I found out my phase shift was 2 pi, and then we go over 8 pi, and we end up at 10 pi. Okay, so now halfway between 2 pi and 6 pi, 4 pi, we're going to end up top. At 8 pi, we're going to end up down here. So I've got this. I was just going to ask that question. Why did we go down up here? Because it's negative. This one's positive, so it goes up. Shay, do we need to move to a different spot? It looks like you're a little tired today. Okay. Come on. I'm trying to help you. I'm not trying to pick on you. Okay? So, this one. Woo! 68. And then from there it goes up 30, down 30. Gee, I wonder what I'm thinking about. I'm thinking about temperature. It's not necessarily going to be of this location. Okay? So we're going to go 68 right here. From here, we're going to go up all the way up to 98. And then we're going to come all the way down to a wonderful, balmy 38. So this might be more of a southern climate or maybe more of a tropical climate or something like that. Okay, where it doesn't get crazy hot. Are you okay with this part so far?
Yes.
Okay, good. Because now we're going to flip the script here pretty quick and we're going to go backwards. I'm going to give you a graph and we're going to have to find the equation.
Actually, it wouldn't be that hard.
Well, we hope not. That's why I'm working hard to lay this base.
The only thing that's going to be hard is like inside the curtains.
Yeah, we'll have to see. We'll have to see. Okay, so this one here. What? My period is what? 12 pi? Close. Oh, you know what? I forgot x. There should be an x here. Oops. That might be important. So what's my period? I haven't heard it yet.
13.
Nope.
Cool. Okay. So.
12. My period is 12. What?
Oh, it's just
12 pi. It's just 12. Why is it just 12? Okay, I've run out of room here because right now my b is pi over 6, right?
Is it x pi or just pi?
Pi. It's pi over 6 times x.
Oh, okay.
Okay? Just because the x is my input. Okay? So if I go 2 pi over 6 is 2 pi times 6 over pi. And notice my pi's, they cancel. And I get my period to be 12. Okay? My period is 12. Okay?
Oh.
I love teaching you guys something brand new you haven't seen before. This is great. Okay? You guys are like, well, I don't know. I'm on the fence, Rex. I don't know about this. Okay? What's my phase shift? My phase shift, remember, is negative c over b. Well, so it is 11 pi over 6 over pi over 6 equals...
It would be 11 pi squared.
No. No, no, no.
Sorry, guys. Geez.
11 pi
11 pi
over 6.
over 6 times 6 over pi.
Oh, 11.
You know what? This is a terribly written problem.
I didn't cancel pi.
Because my period is 11, period is 12, and I moved it over 11. No, it just starts way over. Gosh dang it. So here's 11. And then from there, my period is going to be, it's going to take me all the way over to 23. But you know what I would do instead? Do we have to go to the right? We could have come back this way 12 units and go to negative 1. Why? Because I could have gone 12, in this case, months is what I tried to do. 12 months to the right, 12 months to the left. We could do either one. Does that make sense? We go either way? Okay, good, good. So now let's go ahead. I'm going to make my box right here. Once we get our box set up, then all we got to do is draw a cosine. Cosine, where are we going to start? Middle, top, bottom?
Top.
No, yes. So, no, yes. So we got this. Where's it going to end?
Top.
On the top. Okay. Okay, now here's where we have some issues now. Because I'd like to find out where these intermediate points are. What did you say?
5.
I heard it. 5. Rollo says 5. Is Rollo right?
Yeah, it's in the middle.
Because it's in the middle. It's the average of the two. Okay, so this is going to go down right here. And then halfway between 5 and 11 is 8. So at 8, it's going to be back to midline. And at 2, it's going to be back to midline.
523.
So it's going to continue to do that same thing. Okay. Question, is this a northern hemisphere or southern hemisphere temperature?
That's southern.
Why?
Southern. Yeah. It looks hotter. 38 degrees is not the same.
Well, let's think about it. So if the fifth month is May, right? Okay. That's not too far away. May. So then that's be where it's the coldest, which we're used to it being the warmest. There's actually a couple places in the world that it's double cyclic because it's kind of got where its period is actually twice as often. It's weird, but I don't want to get into that with the time that we have. Okay, here we go. Here's what we're going to do. You might have to go back and get a different piece of paper. I'm going to steal this drawing. I'm going to add a couple points to this drawing. This value is 27. This value here is 3, 15. I am going to pull out a blank piece of paper. I originally thought I'd leave some room here, but I kind of neglect to do that. Okay, here we go. What's my amplitude? 4? Why? Exactly. There's a formula for amplitude, but rather than stick with a formula, I want to talk about why this makes sense. 15 is my highest. 7 is my lowest. What's in the middle? Or I'm sorry. Well, we could do two things, okay? So 15 to 7, that's 8 units, right?
Yeah.
So halfway must be 4. Okay? There is a formula if you want to write it down. Do you want the formula? Okay. So let's go back to here then. A equals max minus min divided by 2. But you know what? I would rather not. I'd rather have you not memorize formulas. I want you to understand what the amplitude is and how it relates to those things. Because if you think about it, how much did it fall? 8. Okay? Well, half of that was my amplitude, so it's 4. Okay? So my A in this case, my A is 4. What else can I tell? Oh, I started at 3. We can do it either way. Let's do cosine. We can do cosine. So what 3? So let's use better terminology. When we say start at 3, does that mean my height, my horizontal, what?
I know your period is.
What's your period?
34, right? Because if you're going from 3 to 20, you would have to subtract those so you get 17.
Uh-huh.
And then add another 17, and you would get the other side.
Perfect. It took 17 horizontal units to get from my high to my low. So to get back up to my high would be another 17 units. Okay? All right. Hey, do you want a formula for that?
Sure.
My period is equal to x max minus x min doubled. But I've never used these formulas. I like it how Sam and what's your name again? Gigi. Okay. I like how Sam and what's his face were able to figure that out without using a formula. Okay. So what is that? What does that tell me? So wait. My period is what? What'd you say? 34. So how are we going to figure out what's that going to tell me? Well, that is 2 pi over b. Can I find my b then? Yes. Yeah. You cross multiply. 2 pi equals 34b. b equals pi over 17. Technically. That's the yucky part. You got to use your formula for a period. Pi over 17 is my b.
Instead of 17 is the midpoint? Or halfway through?
No.
So that's what
Because on the last one, pi over 6, we found out the period was 12. So, yeah, there's a direct correlation there. Honestly, I've never noticed that before, so you're very observant, young man. Okay? So I know my A, I know my B. What else can I find? All we got to do is 2 things left. I got to find my D and my C. And we have 4 minutes. And then maps testing for the next 2 days. So your assignment's not going to be due till Friday. D? Come on. D.
Should be 8.
Nope, it's not 8. 11. Can you explain why it's 11, Mr. Popkin?
your amplitude is 4, so I just subtracted 4 from my 15.
There you go. Or, let me ask you this question. How do we find the middle of 15 and 7? What's the term that you've learned back in 3rd grade? No. Probably average. Mean. Okay? So it's probably the average. You just add them together, divide by 2. Or you can do whatever you want. So my D is, what'd you say, 11?
Yeah.
Okay. We have one thing left to find. My C. My C involves my phase shift. Oh, yeah. This is my phase shift. My phase shift is equal to negative C over B. We know our B, don't we? We know our B and we know my phase shift, don't we? What's my phase shift? So don't worry about C, but what is my phase shift? How much has my cosine graph been slid over? 3 units. Nice job. Okay. So 3 equals negative C, which I don't know what C is, but I know that my B is pi over 17. Yep, cross multiply, and we get negative 3 pi over 17. And I don't have it zoomed out enough. That's why I wanted to be efficient with our time today, because that's a big deal. That's a big ask. So here we go. Y equals, my A is 4. I decided to use cosine because I started up here. Okay? Cosine of B, pi over 17, don't forget my X. And then minus 3 pi over 17, and then what? Plus 11. Boom. Okay, we don't have much time, but could I have done this with a sine graph? I actually could have, but here's what I would have had to find. I would have had to find this point right here, which I could have done. Because from here to here, let's use my colors. From here to here, this was 17. Could I find out where I was at horizontal? Let's see. That's 17. So this was 8.5. So if I'd go 8.5 units over here, I could have seen where I was. I could have used sine. It would have been more of a pain. Cosine's nice to use in those particular situations where you know your highest or your lowest.
I have a question.
What's your question, sir?
So, like, what's the starting x force and the ending x force? Say you give us a formula, bx plus b.
Oh, when you have something more complicated like this, and you want to know where your graph cycle starts, and but you don't have to use that. If that just confuses you, then don't use it. Okay. So this is due Friday. I'm not going to take the time to write this out again. And I will try and get it to where you can see it. I'm trying to get out of the way of the light. So 15 through 9. Let's see. I'm going to change this just a little bit. Yeah. You know what? Yeah, it's just 15 through 19, odd. And then those down bottom. When's this due again? Friday. Sweet. You guys did great today. Nice job. Heard from a lot of different people today. Tomorrow, come in and get ready to crush this MAPS test.
I'm going to get 22.
It's 22?
Yep.
I'm going to go
Totally.
go for a new low.
First one.
We have our pre-ACT test Tuesday.
Next Tuesday?
Yeah.
Okay, I did not know that.
Yeah, we'll be in this class. So. It's
Okay,
first,
so let me ask a question.
First half of the day is when we take it.
Okay, does everybody take the now? Is it the pre-ACT
No.
or it's the
this
PSAT?
ACT practice.
It's an old ACT that they're reusing.
Oh, okay. So it's
So just
ACT.
junior
It's
college.
ACT practice. Okay.
You take the real ACT, everybody else will take a pre-ACT. Except for seniors, they won't have to.
So when we
Got it.
actually take it. all the
Got it.
classes.
Okay, got it. Every school does it differently. Yes, sir. Oh, yeah. That was a flurry of all flurries there. Okay, that was for the other class. I think it got set somewhere. Is it in the book here? Huh. Sorry that, I didn't mean to be a pain for you.
No.
Can you pop back in? I'll pop back in later this period and I'll find it for you. Oh, here we go. Nope, that's not you. Okay. Let me stop my recording here real quick. Whew, that was a long one.